In this video, I'm going to show you how to use the nFront password filter product to configure a feature that we call length-based password aging. The concept is pretty simple. We want to allow users who choose longer passwords to keep them for a longer period of time on the network. So on this particular machine, we have a Windows 2012 R2 server. We have this configured with the nFront product with two password policies. The default policy is configured for regular users. It's a minimum 8 characters. Password must contain a number, cannot contain the username or any part of the full name, and we're also using a dictionary to block some very trivial passwords. We have policy 1 configured to target domain admins, requiring 15 characters or more. So a pretty reasonable password policy, a nice best practice with a couple of policies there. And what I'm going to show is how to do the length-based aging. So with the length-based aging, you can have up to 4 different password aging bands, if you will. In this case, we're going to do 3 of those. We're essentially going to penalize users who've chosen an 8 or 9 character password by forcing them to change every 60 days. If they've chosen 10 to 14 characters, we're going to allow the password for up to 120 days, and if they choose 15 characters, we're going to allow that for up to 365 days. Before we get into the GPO configuration, I need to show that in the Active Directory, you're going to need to pre-create some groups. These groups can be placed in any OU, but they must have this exact group name. They must be called nFront Expiration Group 1, Group 2, Group 3, and Group 4 if you're doing the 4th aging band. Now these groups are newly created. They are empty at the moment, so we see there are no members in any of these groups. And what you're going to see once we configure the GPO with the length-based aging, as users make choices of different password lengths, they're placed into the appropriate group, and our password expiration service is going to target the different groups with different max password age. So we're going to minimize that. We're going to go out to the GPO, and as I mentioned, the default policy in policy 1 is already configured. We're going to configure the length-based aging. So this is very simple. We'll enable it. By default, it does want to email warnings to those who are within or targeted by the password expiration based on this aging. When you configure the parameters, you can go in any order you wish. I tend to go in order from the shortest password to the longest password. So 8 character passwords will be allowed for 60 days. 10 character passwords will be allowed for 120 days. And 15 character passwords we are going to allow for 365 days. The 4th age band we'll leave set to all 0, so it will be skipped. And again, you can do these in any order, it doesn't matter. It probably makes it a little more readable if you go from shortest to longest with regard to password length. We'll say OK there. On your production network, you're going to have the settings configured for the password expiration. In this case, I do not have an email server configured or the other parameters. However, I'm just looking at a local log for this example purpose, and I want to change the warning interval from a default of 14 days. I'm going to change this out to, say, 400 days. So anyone who newly changes a password, they're going to be within the 400 days of the warning interval because we're using the parameters of 60, 120, and 365. So this should allow me to capture everyone in the log. I'll say OK there. We're going to save these settings. We're going to do a GP update force to get those settings into the registry. And once that is complete, we're going to do some password changes. So now I'm going to change some passwords on a few test accounts. So we'll choose test user number 500, and we're going to set a password of BlueFrog1. That's a 9-character password, should put us in the 60-day band. We're going to change the password for test user 501, and we're going to make this a big BlueFrog1, so that gets us beyond the 10 characters. And we're going to also target one that's 15 characters or more, so we're going to do test 502, and we're going to say a very big blue frog 1. So now we have 3 different variations of password length. Just to show, those users are placed in the appropriate group, so group 1 should contain the one with the weaker choice. Group 3 should contain the user who made the better choice with the longer password. And now at this point, The expiration service typically would be scheduled via your task scheduler, and it would run and update the log file and email the appropriate users. In this case, since we're going through testing pretty quickly, the users have been added to the groups. We have a background service called the group filter service that runs every 5 minutes to determine who's a member of what group. So I'm going to restart that just to accelerate that. And after that's finished, I know it's aware of who's a member of which group. I'm going to start the expiration service, which will generate our report. Typically, the expiration service would run once per day. So now we can inspect that log file generated by the expiration report. And in the log file, we see our min length and max age bands here set to 8 and 60, 10 and 120, 15 and 365, and each of those users who are dropped into the different groups are targeted with a different max password age. Of course, they have a newly set password that is 0 days old, and that is why I set the warning interval to such a long interval of 400. So this gives us a nice example of how you may choose to implement the length-based aging. The parameters are up to you to set those to what you feel is appropriate on your network, but this can give you a lot of flexibility and can encourage the use of better passwords, which are longer. So hopefully this will result in users making better choices of longer passwords and being able to keep those for a longer period of time.